Hello everyone, my name is Zhang Haoyu, and now I'm introducing some 5G development. As we all know, global 5G development has been in the fast lane, accelerating the implementation of 5G applications. 5G network covers nearly one-third of the world's population. As of the end of October 2022, 233 telecom operators in 88 countries around the world have declared to start offering 5G services. The population coverage of 5G network in Europe, the US, Asia, and other countries has exceeded 50%. It is expected that 5G networks will cover one-third of the world's population by the end of 2022. There are some applications in 5G in our industry. For example, first is the 5G plus smart factory. So 5G in the smart factory application exploration results have initially appeared. 5G smart factory integration to promote the development of general purpose applications. General purpose 5G smart factory convergence promotes the development of general purpose, including the combination of 5G and industry, VR, AR, ultra high definition videos, drones, robots, and etc. And 5G plus smart grid is also very important in applications. With the accelerated promotion of carbon peaking and carbon neutrality, energy production is accelerated and clean energy consumption is highly electrified. Energy allocation is increasing leveled, and energy utilization is increasing efficient. The connotation of the new power system digital technology support system mainly includes the integration of a physical power grid and a digital system, electrical carbon control system and information system, digital empowerment, and management of the optimization in 4 aspects. 5G is an important strategic resource and a new type of infrastructure to support energy transformation with features such as high speed, low latency, and large connectivity. With the development of a new generation of information and communication technology represented by 5G, the transportation industry has accelerated digital transformation and intelligent upgrading. Smart transportation in the direction of digital infrastructure, the intelligent means of transport service facilitation, and modernization of industry governance is accelerated by 5G. The development of 5G and intelligent transportation promote and support each other, and the intelligent transportation can deepen the development of 5G, while the continuous development of 5G. The 5G continuous development can promote the continuous improvement of intelligent transportation to a great extent, so that it has more diversified development forms and more advanced technical indicators in the subsequent development. The intelligent house construction is to smart city construction as the goal. The comprehensive use of mobile internet, cloud computing, big data, Internet of Things, and other modern information technology actively promote the housing and urban construction field, business management wisdom through the construction of the exploration, manage service, and so on. The smart housing and urban rural construction is to actively promote the wisdom of business management in the field of housing by building and exploring a wisdom platform that integrates urban construction management and service, and promoting the information management by using modern information technology such as mobile internet, cloud computing, and the Internet of Things. 5G application scaling is a long and difficult process, and it's a long-term systematic strategy task, especially in vertical industries. The speed of 5G applications proliferation depends not only on the maturity of 5G and other related technology, but also on the industry's own informatization process, needs, and requirements. The speed of 5G application diffusion depends not only on the 5G and other related technology, but also on the industry own information process, the urgency of demand, and the industry development environment. Thank you.
(600 to 900 MHz), giving download speeds a little higher than 4G, 30 to 250 megabits per second. Low-band cell towers have a range and coverage areas similar to 4G towers. Mid-band 5G uses microwaves of 1.7 to 4.7 GHz, allowing speeds of 100 to 900 megabits per second, with each cell tower providing service up to several kilometers in radius. This level of service is the most widely deployed and was deployed in many metropolitan areas in 2020. Some regions are not implementing the low band, making mid-band the minimum service level. High-band 5G uses frequencies of 24 to 47 GHz, near the bottom of the millimeter wave band. The ITUR has defined three main application areas for the enhanced capabilities of 5G. They are enhanced mobile broadband, ultra-reliable low-latency communication, and massive machine-type communications. Enhanced mobile broadband uses 5G as a progression from 4G LTE mobile broadband services, with faster connections, higher throughput, and more capacity. This will benefit areas of higher traffic such as stadiums and cities. Ultra-reliable low-latency communication refers to using the network for mission-critical applications that require uninterrupted and robust data exchange. The short packet data transmission is used to meet both reliability and latency requirements of the wireless communication networks. Massive machine-type communication would be used to connect to a large number of devices. 5G technology will connect some of the 50 billion connected IoT devices. Most will use the less expensive Wi-Fi, drones transmitting via 4G or 5G, will aid in disaster recovery efforts, providing real data for emergency responders. According to Shannon's theorem, the upper bound to the capacity of a link in bits per second is a function of the available bandwidth and the signal-to-noise ratio of the link. 5G increases the data transmission rate by increasing the bandwidth and lowering the noise in the formula. Specifically, it includes the following three methods. Use millimeter waves to increase bandwidth. Apply more advanced beamforming to improve the signal-to-noise ratio. Massive multi-input, multi-output are used to improve bandwidth and signal-to-noise ratio. At present, the 300 MHz to 3 GHz spectrum used in the first to fourth generation wireless communications has the advantages of penetration and wide coverage, but there is a very fatal disadvantage. The frequency band is too narrow, and there are many wireless devices in this frequency band. The spectrum allocation is about to dry up. In order to transmit large capacity and high rate data, the only available spectrum can be found over 3 GHz. The oxygen absorption frequency band and the water vapor absorption frequency band in the millimeter wave spectrum cannot be used for communication. Therefore, the millimeter wave frequency band has a total bandwidth of 252 GHz. In fact, the millimeter wave frequency band allocated for 5G communication network in the spectrum of various countries is about 3 to 6 GHz. But this is enough to increase the data transmission rate by more than 10 times. In contrast, 1G to 4G communication network are all crowded in the frequency spectrum below 3 GHz. The base station antennas of 4G networks are mainly omnidirectional antennas, but this is not a good choice for 5G. Indeed, 5G networks are severely affected by complex weather because of the narrow coverage of millimeter waves of 5G and large path loss. Therefore, beam design needs to be improved to focus the transmitted energy to raise the quality of received signals. In fact, the directional beam after beamforming can help improve the coverage of the base station, and the signal energy of the base station is more effective. The multi-antenna system in wireless communication needs to assign weights to each antenna in order to improve the spectral diversity and multiplexing gain. In reality, this algorithm is nonlinear and computationally complex. The more antennas, the more complex it is. But what is surprising is that when the number of antennas is very, very large, simple linear procoding can approach the optimal result very well. But what is massive MIMO in 5G may have a large number of applications. Not only large micro base station, but smaller millimeter wave transmitters may also be equipped with massive MIMO system. Because millimeter wave antennas have narrow beams and short antenna lengths, they are more suitable for massive MIMO applications. Back to the topic, the benefit of massive MIMO is to maximize the use of airspace resources. It can provide multiple beams serving cell users at the same time through beamforming, and can simultaneously increase the user's signal-to-noise ratio and increase the data transmission rate. The latency we are talking about here is round-trip latency, which can probably be understood as the total time required for data to travel between the access network and the core network. Because the propagation speed of ratio is relatively fixed and cannot be compressed, there are two ways to reduce it: reducing signal loss and compressing network processing. Compressing network process is to flatten company hierarchy and decentralize decision-making power. In this way, unnecessary expenses in the network will be significantly reduced. The standard way of compressing the core network is to do not go through unnecessary processing units. In other words, the control structure is separated from the data transmission structure. Of course, there are many other solutions. A better way to compress the network structure is fog computing, which is very popular in the academic world, which is to decentralize some repetitive computing tasks and use wireless access terminals. As computing processing units, this can be used as an alternative computing hack, which greatly reduces network latency. 5G promises to bring tremendous new revenue opportunities for service providers. However, the increase in performance, changes in network architectures, and new technology adoption that come with it also present major security implications. The first one is coexistence of 4G and 5G requires consistent and higher performance security. Like 4G, 5G is not going to happen at the flip of a switch. 4G and 5G will coexist for a long time. In the transition from 4G to 5G, there will be an increase in bandwidth driven by the introduction of the new 5G ratio base station. The increase in bandwidth from 4G to 5G will cause significant increase in performance and scale requirements that currently security infrastructure may not be able to handle. This also means that 4G and 5G network coexist. The security policy for threat detection and mitigation must be consistent and holistic. The second one is more devices and more bandwidth for hackers to utilize. 5G will result in 10 to 100 times increase of connected devices as well as faster speeds and higher bandwidth. While this is great news for consumers and business, hackers will also take advantages of these new capabilities. Many IoT devices are fundamentally insecure and will rapidly become preferred targets for hackers to leverage in cyber attacks. And with more available bandwidth to utilize, hackers can generate more powerful distributed denial of service attack that can overwhelm any organization's network and services. The third one is distributed edge clouds open up new attack surfaces. Distributed edge cloud is an architecture evolution of cloud computing that enables application hosting and data processing to move from centralized data centers to the network edge, closer to where data is generated. In this new architecture, IP connectivity will terminate at the edge of the operator if proper security mechanisms such as encryption and firewalls are not in place. As a result, the edge cloud nodes are susceptible to spoofing and other attacks from the public internet it's also likely that third-party applications will run on the same physical platforms together with the virtual network functions, increasing the risks of exhausting the application resources needed by the network functions, or worse, offering hackers an attack vector to infiltrate the platform. The fourth one is network slicing and virtualization bring new risks. Network slicing is a specific form of virtualization that allows multiple logical networks to run on top of shared physical network infrastructure. With network slicing, mobile services providers can partition their network resources to address a diverse set of use cases. Service providers need to consider how well the virtualization layers and network slices are isolated from each other. The last one is manual operation are not enough anymore to stop threats. 5G infrastructure heterogeneity and complexity will require security to be applied at multiple levels with a combination of centralized and distributed physical and virtual deployments. For previous generations, manual interventions for mitigating threats may be fine. But with 5G now and the fact that the threat landscape continues to grow in volume, velocity, and manual operations are not enough. Security absolutely must be automated. Automated threat detection and mitigation with holistic visibility. That's all. Thank you.